Okay, hello, assalamualaikum, and good evening to all of you. This week, actually, we should have the face-to-face session, but due to the Deepavali celebration, we need to replace it with this recorded video. Okay, so we are going to the second seminar, which is I'm going to explain the detail about the complex engineering problem, and also some explanation how to find and search for your problem to be solved. Okay. Okay. First of all, what is integrated engineering design (IED) or integrated design project (IDP)? Is in the same. Is in the same meaning actually, but just the name of the course is different between the old batch of the student BEP and the all new batch of the BEL students. Okay. All right. So I derived this kind of things from the EAC manual 2020 on page 16. Integrated design projects should involve complex engineering problems. Okay, again, complex engineering problem and design system components or processes integrating, cultivating core areas. We have several core areas for the electrical field under the EAC requirements. Okay, and meeting specified needs with appropriate consideration for public health and safety, cultural, societal, project management, economy, and environmental consideration where appropriate. So the IDPs or the IEDs are multifaceted assignments that serve as a culminating academic and intellectual experience for students, typically towards the end of an academic program or learning pathway experience. So it's actually one of the necessary course to be taken by all engineering students before they graduate. That one of the requirement for the student who will be accredited by this EAC. Okay, the IDP should involve student working in group. That's why I assign you 4 members per group maximum. The program should seize the opportunity to deliver and assess many relevant POs. Sorry, the O should be capital letter through the integrated project. So this is the what definition directly I derived from the EAC Manual 2020, page 16. Okay. Okay, let's go through because I didn't explain this kind of things in our first week because we only focus for what we call that to form your group members. Okay, so first of all, first week, so I give you the freedom to choose your own members. Now we have 23 groups that will be proceed in this IED or IDP projects. Okay, in this subject, so only one credit, integrated engineering design principle BE2971. So in this semester you are not going to have any supervisors, so you are going to prepare your proposals, do the problem vettings without the supervisions of supervisor. So you're going with no supervisor in this semester. Starting from the next semester, with the continuing integrated engineering design with BEE333, that 3 credits, that one you're going to have the supervisor that will monitor all your progress and work. Okay, so this course synopsis. So this course introduce, educate, and develop students to integrate their technical knowledge, engineering skill, blah blah blah. You can read all this, and we have 8 course outcomes, which each of them is tagged to one PO. Okay, for example, the CO1 taken to PO2, PO3, PO5, so 7, 9, 10, 11, and 12. This is all about the descriptions, course synopsis of this BE2971 Integrated Engineering Design Principle. Okay, this is the most important thing that I need you to understand, or I need you to realize that this kind of complex engineering problem or complex problem solving is critical in the work of the IED. Okay, so complex engineering problems are defined. Okay, are defined when the characteristics of WP1 and at least other two WPs, WP2 to WP7 are fulfilled. Okay, what is the WP? It's actually is the knowledge profile. Okay, it's the knowledge profile, and then also is the graduate attributes. Okay, knowledge profile that comes in the WP1 under WP1. And then all the items here recorded as graduate attributes. So we have until 7. This is derived from the Washington Accord. So we are following the Washington Accord, which is stated in the EAC manual. Okay. So we have WP1 until WP7, where WP1 is depth of knowledge, WP2 is range of conflicting requirements, WP3 depth of necessity required, WP4 varieties of issues, WP5 extent of applicable codes, WP6 extent of stakeholder involvement and level of conflicting requirements, and the WP7 is interdependence. Okay, what is this? Okay, it looks become confused. Okay, again, here, your problem after this, you are going to propose your problem. You are going to find and searching for your problem from the industry, from the expert, from the consumers, from the manufacturers, from the anybody, farmers, fishermen, engineers, and so on, who are related, who are currently facing that kind of problem. So after you heard that kind of problem, so you need to recheck, tune your problems so that it can suit with these kinds of WP1, okay, plus another 2 WPs. So your problem, when you have the kind of problems, then you check WP1, which item in this WK, okay, in this WK that suit with your problem. Okay, for example, cannot be resolved with in-depth engineering knowledge at the level of one or more. Okay, in this case, in order to fulfill WP1, you need to have at least, okay, at least at the level of one or more. At least you need to have one from this WK3 to WK8. Okay, WK3 engineering fundamentals, WK4 specialist knowledge, WK5 is engineering design, WK6 engineering practice technology, and WK8 research literature. Okay, for example, your problem requires you to go for the fundamentals of some equations related. So the problem will involve, the solution for your problem will involve this kind of very simple or basic formulation of the engineering, electrical engineering, for example. So that one maybe suit for you is WK3. Other case, for example, the solution for the problem that you're going to propose needs several critical design. It need proper designs that need to be done critically. Okay, that one may be suit with you with the WK5. If something that you need to play with the new technology engineering practice with the practice in the current practice, maybe you can go for the WK6. Okay, or some problems that need to refer all the stuff from journals, from literatures, and so on. So maybe you should with the WK8. For me, for example, is this maybe since all the solution it come with the design, and at certain point it needs you to add to derive some very basic fundamental equation. For example, if you use circuit analysis, then you're going to play with the Kirchhoff or Ohm's law at least, and then real and reactive power, that kind of things. So that one maybe can go to WK3. Once you have at least one item came out from your problem, and then it's already fulfilled for the WP1. Okay, WP1 already fulfilled. Okay, you need to have another two. Okay, another two WPs. So another two WPs are fulfilled. Your problem is complex. Okay, for example, range of computer requirements involve wide-ranging or conflicting technical, engineering, and other. For example, there's some problem that needs you to increase the voltage, for example. But biologically, because of this conflict, then at the same time, the frequency will increase. So what should we do in order to suppress the frequency? Maybe you need to add some equipment, you need to set some components in order to limit the frequency into a certain level while possibly to increase the voltage without limit. For example, that is the meaning of the wide-ranging or conflicting technical, engineering, and other issues. Other thing maybe like the P3 depth of analysis required have no obvious solution and require abstract thinking or generally analysis to formulate suitable models. Okay. For example, disabled person with broken hands, for example, broken for both arms, but he still need to eat. Okay, he still need to eat. But at that time, the food is there, but he cannot eat because the hands cannot be used. At the same time, there's no people there, but he need to eat to survive. You need to come up with a solution that help him to maybe auto feeding, kind of that. But still not sure what type of that solution is not well known. maybe you need to come up with a very new idea, which is not very clear yet. So at the time, that problem, it looks like more not really abstract, but no obvious solutions. Maybe it requires very deep thinking, so it cannot be solved with simple tips. You need to think with the many solutions. We need to think in any other aspects and perspective, okay, in order to solve that thing. Okay, while for the WP4, for example, familiarity of issues, even though they write familiarity of issues, actually involved in frequently encountered issues. Okay, infrequently encountered issues, very rare issues. Okay, that's the meaning. If you think your problem is very rare, then you may tag it under WP4. Okay, right. And then extent of applicable codes. Maybe your solution. Usually this one's quite critical. Maybe we play with the Suranjaya Tenaga, something like that. Your solution maybe relate to the TMB works, TMB groups, and or Suranjaya Tenaga. So you need to refer that kind of standards, IEC standards, maybe Suranjaya 10 standards. Maybe you need to follow JKR standards. If your problem, you thinking your problem need that kind of standards, in order to solve it, then maybe you take it under WP5. Okay, and then WP6, extent of stakeholder involvement and level of activity requirements involve diverse group of stakeholders with widely varying. I think this kind of WP6 is can easily, I mean the you can easily relate with certain projects. Maybe relate because it involves several. For example, your problem will solve the whole community of UMP. If you solve that problem, the lecturers, the students, the technicians, the what we call the securities, the admins also will get the benefits. So when your problem is going to solve the whole nations, I mean that involve many stakeholders or many people that can get benefits from your problem solution, then you can take it under WP6. Okay, the last one is WP7. So it's in interdependence. Okay, interdependence. Interdependence are high level problems including many component parts or sub problems. For me, also this one also easy for you to take. As soon as involve several components part, several problems related, your solution, your problem needs several things to cater. Okay, when it not involve, for example, several component parts. How can I say? You need to come up with the, for example, IoT system, but automated IoT system. So it becomes IoT. They have the technology. I mean the Internet of Things, and then but at the same time you need the components. In the components, you need the motor to move it, and then maybe you have the connection and here and there. At the same time, you need some external force to support the material. For example, you need to think also. You need to calculate how to build, how to construct so that your sensor can be put on top of the table. For example, I'm just giving the nonsense example, but you can think. Okay, you can think. Okay, all right, that kind of things. If you fulfill this kind of things, okay, please, I think it's enough. You get only WP1, only one WK, and other two is enough already. It's fulfill 1 plus 2 already. So when you have one WP1 and you had another two WPs, right? Okay. I hope at least slightly clear. Okay. So in this task, even I explained already, you are required to search and define your problem that has currently became issues or trending in industry, community, or public. Okay. So you're defining your problem to be solved. So it's quite different to the normal nature because we find the title, we find the title, we find the title. This time we are not finding the title, but we try to find the problems that are faced by several groups or several peoples or that happen in the community, in the industry and communities. That's why this issue must be real issues. Okay, must be real issue or training issues that happen in the industry and community or public. Then when I relate to industry, so we can't just talk what do you call that? We just simply create the problems, but you need to find the problems. Okay, how to get the inputs. Okay, you may need to approach or interview some individuals such as engineers, technicians, manufacturers, entrepreneurs, farmers who are facing these issues to get some inputs. This is where you can get direct inputs from the real person who are currently involved in that problem. Okay, So this is real case lah. The real problem, not the created problem. For example, how to solve the problem, generate more PV, like the last semester, for example, most of students using the solar tracker stuff, dual axis, single axis, in order to maximize. That is not the real industry problem, because that problem already solved several years before. It's just the matter of technology. Maybe use the different sensor, ideal sensor, multiple sensors. That's the other thing. But that problem, not problem anymore, is solved already, because they come with the solar tracker, so problem solved. So that's not problem. So please don't repeat that kind of mistakes. Okay. Same goes with the e-separator. Like last semester, it's like several topics about that. But I think I'm not going to hear any more about the e-separator. Electronic separator. You put the garbage one side, and then the garbage will distribute based on the type of waste that you throw in the dustbin, into the dustbin. So they will automatically distributed depends on the glass, plastics, cans, and papers. So that kind of thing. So I don't want to hear any more that kind of thing. That one is already solved. We consider it solved already last semester and before. So this time you need to find the real problems. They must be problem. Even the entrepreneurs, the small IKS entrepreneurs, small IKS business, sometimes they face some problem. So you hear them, you need to get the inputs from them. Level of your problems again, to be solved must comply with the information complex in the problem just now, where the elements of WP1 and other two WPs are required. Therefore, you may tune your problem from the inputs obtained to embed this WP's element. First of all, you hear from the real victim, okay, the real victim or the real people who are involved in that problem. After that, you tune it, and then you try to put this element that I told you. Try to put maybe the WK3 fundamental. Maybe it requires some basis of the electromagnetism, or some Kirchhoff law, or some Newton resistance things, the kind of engineering fundamentals. Then you put there WK3, and then you say this one it cannot be solved just like that. It looks like we need to come up with several solutions. I think that we need to go deeper with the analysis, because the design, the angle and something like that. So maybe you can put WP3, depth of analysis. And the one, maybe since maybe it relates electronic part also have, and it relates several components. It also play with the IoTs. It also play with the Arduino's microcontrollers. At the same time, there's some movement that use motor, and the pressure of the wood also cannot be very light. You cannot use plywood. You need to use solid wood, for example. That kind of things. Interdependence, maybe WP7 can be put there. And then you mark in the probability form. Okay. All right. Hear from the victim directly, anybody that related. Our solution must come to our field, which is electrical. I repeat, our solution must be based on the electrical. Maybe we need to use converter there. There's the power electronic and drive side. Okay, and then maybe use some motor. That one maybe electrical machines. At the same time, maybe you need to do some circuitism. So then once basics, go to basic circuit and signal. So that's the nature branch area of electrical. Okay. Before you propose the solution, you already have in your mind. While tuning your problem, you must be in mind that your problem can be solved with the electrical stuff, electrical stuff, all the things that you learn. Maybe some electromagnetism can be implied there. So that kind of solutions cannot be solved by chemical, civil, or mechanical. So we need to focus on our field, electrical, but different drivers of that signal, circuits, electromagnetism, powers. Okay, like that. But besides, the scope of your problem must be in the doable range, reasonable scale with less budget. So this is the one thing. Avoid, in order to prevent your title to be rejected. Okay, maybe there's some title will be rejected. Okay, if the scope is too big, too large. For example, you try to cater the problem of the large 100 megawatt solar farms, for example, or you try to cater the substations of 125 kVs. It's not doable, because it's too big, too massive, and too risky for that. So try to find, for example, not cater 100 megawatt, which you try to solve the small scale residential rooftop PV arrays in Pekan Pahang, for example. There's one house in Pekan Pahang that use 4 kilowatt peak, and there's problem with their modules. So you try to solve it to detect the hotspot, something like that. very small scale and it's doable. It's not too ambitious. Okay, it's real because you need to solve. You need to come up with prototype on the second semester. So that protect also with come with the less budget. Okay, very less budget. In reasonable scale with the less budget. Don't expect several thousands. I'm afraid we can only get maybe 400 ringgit per group, that kind of budget maybe. So we come in solution, you need to develop by your own using all the stuff that you have, then you fabricate and construct it on the next semester. So your idea, I mean, before you start to decide your problem, also you need to think that kind of thing. Everything must be in your head, okay, before you finalize your problem, right? Okay, I guess I just give the examples. Just examples of problem to be solved. Just examples. Because I found this kind of problems when I visiting student during internship industry trainings, and I observe and involve some very little projects that get direct input from the users or from the entrepreneurs. Okay, okay. For rooftop, for the first one. Okay, for the first one, for rooftop photovoltaic array system, maintenance teams are facing difficulty to inspect which PV modules are broken or spoiled when there are lots of PV module connected in series for each PV string. I'm sorry, I keep using the PV photovoltaic because my field is already photovoltaic. My blood in my bloodline also photovoltaic PV. That's why I'm always thinking about PV from morning to night. Okay. Example. Okay. Maintenance team coming and the rooftop, and then I said there's a problem with the PV string. For example, the voltage is very low. But when they go there, there's a lot of PV modules connected in series. In one string, for example, 20 modules in string, with the large size and with the limited space between the PV strings. So you cannot easily just cross it. You cannot easily step on the modules. So you need to come up with the solution. How can you trace the spoil modules to without, for example, minimize the movement, or maybe you use some, I don't know, maybe we come with the, you see, WP3 is depth of no obvious solution because the size, the space is very narrow and the roof condition also not too stable, and because old stuff maybe. So how can you solve it without, if you try to short skirt everything, it's very dangerous. Maybe you need to use other things like clamper to solve and some came up with circuits, then maybe use the reflection of the sun. You put some mirror, something like that, to there, and with the correct angle. At the same time, you can measure the voltage from there, from the first module. No need to go to the seventh module or the eighth module that I have problem with that. For example, that kind of thing, solution. No obvious solution. So measuring PV module one by one will take lots of time. And so that's the problem. If you try to check if there's 30s in one string, you're dead. You're going to be dead because spherical is constant a lot of time to take it out one short skirt, try one by one, next, go next, and with the narrow space, it's risky and dangerous at the same time. Okay, so that's one maybe problem. If you can solve this kind of problem, came up with solutions. I believe there's solutions. So that's what you're going to do. Okay, that's what you're going to propose in your final report. I mean the proposal report in this semester. Okay, the second one. The second one, uh, though the project is totally is not electrical, but the solution is critical. Okay, for example, in mushrooms cultivation activities, they are growing mushroom in a greenhouse. Okay, in the greenhouse, it's not simply made by concrete. For example, maybe some wood, some also not really proper, no proper structure like the building. So the internal temperature and relative humidity must be maintained at certain range of value in order to ensure the growth of this mushroom is in the best condition for commercialization to penetrate the market. So we need mean that what is the problem there? The internal temperature and relative humidity must be maintained at certain range of value. If too hot, the mushroom will be spoiled. Once spoiled, you cannot sell it, then the entrepreneur will face the loss. Okay, the loss of money, the loss of time. Then they need to redo it back, and if it's not properly done, it looks like simple, but it actually can come out with many solutions there. Yeah, of course you put sensor, but at the same time you cannot simply put sensor. What will happen if the water, if the rain coming, if there's too humid? What you can, what we can do, what you need to do, that kind of things. Maybe one of the solution that we can solve with the electrical stuff, with the electrical field, our area. not using the mechanical or civil or chemical stuff, chemical things, but we can solve it. We propose, we can up with solution. It looks like we have solution, uh, then maybe this one, maybe since it relates, relate with the sensors, but at the same time you need to monitor, what about the structure, how can the water flow very well, so that if too much humid, what should you do, you need, do you need to put the extra fan or something like that, so that kind of thing, or they put humidifier, I'm not sure about that. Okay, if too hot, what should we do, put air conditioner, that solution is still, there's some solution there. I think that's one of the example that you can take, for your problem to be solved. Okay. Otherwise, you can try to ask anybody after this. Okay, start from this moment. You can start to ask people. Right. Right. I give just an example there. You may refer some ideas of problem-based succeeded grants from the homepage of Public-Private Research Network, PPRN, at this page. Okay, yep. Let me show. Let me show you. Uh, okay, this example of the succeeded project. Okay, such a project, they are awarded a grant. Okay, they are awarded a certain amount of grant. So they coming from USM, UTHM. So there's, for example, some smart size sorting system, tapioca peeling machine, modernization, for example, just example, artificial intelligence, convention based material to software development, and reclaim rubber technology for repollutant and so on. So that kind of thing also can be reference also. Other than you ask directly to the person, maybe from here also you can get idea. So this is the, what we call the real problem. Or you can approach this kind of company if you brave enough. You can approach the company if they have some problem. Okay, so that you try to solve it. It doesn't mean that we need to collaborate with them, but just asking them politely. Do you have some problems? We are currently doing the survey, our project. We need to come with the real problem that we try to solve. Okay, in our limitation. All right. Okay. Oh, sorry. Okay. So the task for you. Okay, the task for you. So please fill up all the items stated in the problem vetting form updated versions. I already uploaded the new updated version of the problem vetting form. The difference is only here because the previous one doesn't have the group number, group members, and so on. So put your number, group number. Oh, sorry, group number and group name. Okay, group number together with the group name, and then your leader name, and then other three members. Okay. And then background problems, you might explain it based on what you're finding, and then this is the problem that you're going to solve. Okay, who is the stakeholders who are currently involved with that? If you can disclose the name or the personals, then you can put here. Okay, for example, the mushroom entrepreneurs in Gambang. Okay, Gambang company CD Holding Berhad, for example. And then what solution? So this is your solution. And then the objective is to solve the problem. Originally from problem to be solved also. For example, the internal temperature, try to maintain at the temperature at, for example, 28 degrees at maximum, while maintaining humidity more than 85%. For example, okay, for example, right? Specific requirement, safety, working on project need the special permission, for example, special permission from the authorized person. For example, other than safety, elegance, easy maintenance, cost-effective, if you can put specific requirement too, then it's better lah. Okay, it's better. Aesthetics, or the consumers, they want it proper looking. For example, so just maybe aesthetics, that is the meaning. So this is what I'm saying. For example, WK3. For example, just now we have involved some equations, some calculation based on the determinism, use the Kirchhoff law, or there's some understanding about the apparent power. So involved with the process principle of control system. For example, okay, then WP3, this one, no observation until at this level. There's no solution yet. It can come with several solutions that are not prevalent yet. So this is what we go to. So this kind of discussion, you write it. So you need to think. Discuss with the group. Okay. And then please attach the evidence, including screenshot or photo or meeting with the related individual. So I need you to attach together during your presentation, vetting presentation that will be done on the 7th November at 7th November at 2 to 3:50 p.m., which is the next Monday. Yeah. and then Monday. If there's some change, I will inform later. Okay, I will announce later. Alright, please at the time during your presentation also you attach together, because you also need to submit your probability form before 7 November at 10 a.m. the same day, but 10 a.m. at the time you attach together your screenshot photo, Gmeet screenshot and so on, or you go directly face to face, take some picture as the proof. Okay, and then select correctly which element of the WKWP is suitable fit your proposed problem to be solved. Do not include many WKs or WPs that are not related. Remember, don't put everything. It's enough, only sufficient with only one WK and two WPs. If you get more, it's okay, no problem. But if you try to put all the things but not related, you're going to be bashed during the presentation. So submit probability form. I will give the Google form later before 7 November 10 a.m. Okay, this not next week, next 2 weeks. Okay, next to Monday. And then prepare for your probability position. No need slides. You just present the word format that I gave you just now. Okay, so this is the original plan. 7 November. Oh, sorry, 2022. Sorry, this is 2022. Sorry. From 2 to 3:50 p.m. at the same time our timetable with IEDP. So we are try to not to touch other time class time. Okay, I think that's all. Okay, I'm so sorry because this is quite rushing for me to do this video. So I hope you can understand, go through with the slides. If you have some problem, just PM me. Okay, just WhatsApp me. Right.